Okay, students, so this is third method of computation for GVF profiles. This is standard step method, and this is mostly used for natural channels. Okay, see the diagram or the sketch. This is as usual datum line. This is bottom slope S naught. This is top surface line SW, slope of which is SW, slope of energy line SF, section 1, section 2. At section 1 we have this as Z1, Y1, this as V1 square by 2G. Okay, so this total height we call this as a capital H1. Okay, and Z1 plus Y1 we call this as a small h1. This is new notation in this. Okay, so on this side as well, this is Z2, this is V2, this is V2 square by Y2, this is V2 square by 2G. Okay, this is HF, head loss between section 1 and section 2, and this is additional loss HE. This is total head loss, out of which this is frictional loss and this is eddy loss. Okay, and this is capital H2, that is Z2 plus Y2 plus V2 square by 2G is capital H2, and small h2 will be Z2 plus Y2 as in the section 1. Okay, see this diagram. Okay, this is horizontal line connecting section 1 section 2, showing points of same energy. Okay, but we know energy does not remain same, it goes on decreasing. So at section 2 it has decreased by this amount HE, further by HF. Next, now the theory. In natural channels, cross-sectional area as well as shape of channel varies from section to section. Okay, so in natural channel, loss of head is due to form change or eddy loss. Okay, okay. Uh, in addition to friction loss. So in friction loss is a regular thing, but here in natural channels, as the shape of the channel changes too much over given length, so additional losses in the form of form change or eddy loss occurs there. Okay, the equation used in earlier method, direct step method, dx is equals to E2 minus E1 upon S0 minus SF. This does not take into account eddy losses and hence cannot be used for natural, that means non-prismatic channels. Okay, so this theory is important as a comparison between standard step method and direct step method. Okay, so standard step method can be used for natural channels. Okay, but whereas direct step method cannot be used for uh, natural channels or prismatic channels. Okay, so what is prismatic channel? A prismatic channel is having same cross section throughout its length, having same uh, properties of material all around. Okay, so that its material does not change, its cross section does not change, its shape does not change, etc, etc. Okay, uh, so the energy equation used. Okay, so Bernoulli's theorem, z1 plus v1 square by 2g plus y1, and this is equals to z2 plus y2 plus v2 square by 2g. So obviously on section 2 side, the flow is coming from section 1 to section 2. We have added HE plus HF, head loss due to eddies plus head loss due to friction. This is total head loss between section 1 and 2. Okay, so HF, frictional loss, and this is equals to SF bar dx. This we have derived earlier uh, when the direct step method was being discussed. And HE, this is form loss over a length dx. Okay, HE may be appreciable in case of non-prismatic channels. Yes, because there are frequent changes in the shape, so HE is appreciable in case of natural channels, non-prismatic channels. Otherwise it doesn't play much greater role. Okay, next, no rational method is available for finding HE. Okay, but generally HE is expressed as k into bracket v1 square minus v2 square by 2g, where obviously k will be some constant, v1 v2 will be the velocities at section 1 and section 2. Okay, so k is a constant, value of k 0.1 to 0.3 for contracting flows and 0.2 to 0.5 for expanding flows. Okay, where the cross section is increasing and decreasing, contracting and expanding. Okay, sometimes the Manning's n value is suitably increased to account for eddy losses. Okay, this is one. Next, height of free surface above datum is called as stage. Okay, so this is new thing. The quantity z plus y is equals to small h. Okay, that we have already shown in the figure. H, z plus y, this is it, small h, this is h1, z plus y, small h1, z plus y, small h2. Capital H2 and small h2, those are different. Capital H2 refers to total head. Okay, next, equation 1 can be written as h1 plus v1 square by 2g is equals to h2 plus v2 square by 2g plus hf plus he. Okay, but we know h plus v1 square by 2g is equals to capital H, that is total head. So capital H1 is equals to capital H2 plus hf plus he. Fairly easy to understand. Okay, next, this is the basic equation used for standard step method. The computations are carried out in steps from station to station where hydraulic characteristics are already determined. Now this is difference between the standard step method and the direct step method, which we talked earlier. Okay, next, in direct step method, the distance between two stations with known depth is determined. So the distance is determined and the depths are already known. Okay, while in this method depths are determined at known distance, known values of distance between the stations or between the sections. So in direct step method, distance between two stations is distance between two stations with known depths. So depths are known, distance is determined, but here distance is known and depths are determined. Okay, that is the difference. Next, thus knowing the discharge Q, depth of flow at control section 11 at 2 okay, the hydraulic characteristics at the two sections of the value H2 in the above equation can be known. Okay, value of H2 is required to find H1 at section 11. Okay, lot of trial and error is involved in such calculations. Okay, okay, I think this is sufficient for one video. In next video we will discuss the detailed procedure for standard step method. Thank you.